This is problem number 8 from the problem set. Okay, so in this problem, this is another typical problem. In this problem we have a bar or a ceiling, and from this there's suspended 2 strings, right? And through this string, these wires is attached to a weight W, right? And they want us to find the tension in the left wire, right? And the thing that gets most people is when they specify the left wire, most people get thrown off. Why the left wire? Why not the right wire? Well, to be honest, we'll find out soon that the tension in both the wires is identical, but in different directions. Okay, so let's get to it. So if you have a mass of mg, let's say, mass m, and whose whole weight is given as W in newtons, as 120 newtons. 120 newtons. We have 120 newtons weight hanging from these strings, right? And they found out that these angles that they make are 37 degrees, right? And they want us to find the tension in these strings, right? Now, there is no reason, if the angles are the same, right, then the tension in the strings will also be the same, right? Now, if you draw an axis, right, that goes through this point of intersection, splitting these tensions, we have, then this angle is also theta, and this angle is theta, by the parallel axis theorem from your high school geometry, I guess. These are 2 parallel lines splitting them, so this angle is equal to that angle, right? Now, so if you take the vertical component of the tension, it's t sine theta, and we take the horizontal component, it's t cos theta. Now, the thing is that this t cos theta and that t cos theta, they both cancel out, so we're only left with the vertical components. So we have 2 t sine thetas, and they are balanced out by the weight of this body hanging, which is W or mg, right? So instead of giving you the weight, they could just give you a mass, and you have to just multiply that by g. Okay, so the equation we have is 2t sine theta is equal to W, or t is equal to W by 2 sine theta. Plugging that in, we have, if you plug all that in, we get tension is equal to 99.7 newtons. Okay, so what's the concept here? The concept here is supposed to understand that these tensions, when they're at a diagonal or are not perpendicular or horizontal, have to be split up into components, right? So once you do that, once you split them into components, the problem simplifies to basically identifying what balances what, right? Now, obviously, these 2 tensions, which are the horizontal components, are in opposite directions, so they balance each other out. And then we're left with the vertical components, which are balanced by the weight of the body hanging. And writing a simple equation from that, we get 2t sine theta is equal to W. And plugging the numbers in, we can find the tension in the left wire, which is equal to the tension in the right wire. So either way, that's the solution. Alright, thank you.